Hi kids. This video is about negative numbers, the trickier aspects of multiplication in particular. We first learned about multiplying that if I multiply a positive times a positive, it's positive. I think you know that. We also learned that if you multiply a negative times a positive, in other words, if I have 6 groups of negative 6, that equals negative 36. Leads us to the final case of a negative times a negative, which is a variation on the opposite of 6 times the opposite of 6. Those two opposites more or less reverse each other and it becomes positive. So same signs give us a positive. This leads us to the extension of when I'm multiplying more than two numbers at a time. A time. Since I know that any two negatives create a positive, I can look and I can say, okay, if I'm doing negative 2 times negative 3 times 5, what would the answer be? Okay, now I don't know how to get to the next slide. Negative 2 times negative 3 times positive 5 is the problem at hand. Well, we know from multiplying two numbers at a time that these become positive 6. And when I multiply that by positive 5, it equals positive 30. So, when you are multiplying numbers more than two at a time, count the negative signs. Since any two negatives create a positive, you can think that's a positive and that's a positive, so an even number of negatives equals a positive. An odd number of negatives equals a negative. We can just use the example of negative 1 times positive 1 times negative 1 times negative 2 times negative 3 times positive 2. How many negative signs do I have? 1, 2, 3, 4. These two make a positive. These two make a positive. There are no positives left, or no negatives left, so the whole thing is positive. 1 times 1 times 1 times 2 times 3 times 2 is equal to positive 12. Let's just do one more example like that so that you can see. If I have negative 4 times negative 2 times 2 times negative 3. I count the positives. These two give me a positive. Now I have a negative left over. This is positive 8 times 2 times negative 3 is negative 48. This leads directly to the whole notion of raising a negative number to a power. First of all, what does negative 2 to the second power mean? It means negative 2 times negative 2. I know from what we just talked about that those two negatives make a positive, and therefore this equals positive 4. What about negative 2 to the third power? That means negative 2 times negative 2 times negative 2, which is 1, 2, 3 negatives. 3 is an odd number, so this comes out to negative 8. What I know from this is negative number raised to an odd power, whoops, equals a negative. For the same reason of counting all the negative signs, an odd number of negative signs gives me a negative number. A negative number raised to an even power equals a positive, because an even number, positive, an even number of negative signs always gives me a positive number. Remember, a positive number raised to any power is always going to be positive. We don't have to worry about those. We only have to worry about when we're raising negative numbers to the power. This leads to what may be the trickiest thing of all. If I look at this problem, I say -6 squared. This means -6 squared. It's a negative number raised to an even power, which gives me a positive answer. This is not to be confused with the opposite of 6 squared. When I'm thinking about the opposite of 6 squared, what I have to do following Gremdas is the exponent first. So I'm going to erase this for now and just say, what is 6 squared? Well, that is 36. Oops, what's happening? When I take the opposite of that, I get -36. So you read this problem, -6 squared, whereas this one is the opposite of 6 squared. If you wanted to, you could think about the parentheses going around just that number, because you're doing 6 squared first and then taking the opposite of it. Some things beyond that, the other most common confusion that kids have with these whole negative numbers is going back to a problem like -3 times -4 times 5. Okay, so I've got two negatives here, which means I know I'm going to have a positive answer. This is 12 times 5 times 5 is equal to 60. Positive 60. Sorry about this. That's 12 times 5 is positive 60. Some kids get this mixed up with the whole notion of adding integers, where the one with more gets the sign. It has nothing to do with that. When I'm adding integers, if I have the like signs, I add them. Positives to positives equal positives. Negatives added to negatives equal negatives. If I add a positive and a negative, they battle, and the winner is the one with more. That is not the situation when I'm multiplying. Okay, finally, we're going to evaluate where if x equals 2 and y equals -3, I'm going to do a couple of problems. What is x, y squared? Well, as you know, you must show replacement first. So 2 times -3 squared. I have to do exponents first. By the way, this is not considered grouping symbols because nothing's happening inside the parentheses. I am raising -3 to the second power. A negative number raised to an even power is a positive. And then I bring this down and I don't change the order. 2 times 9 is 18. Another one where x is 2 and y is -3. How is that different from x, y squared? Well, first I'm going to do replacement, show replacement 2 times negative 3 squared. And I'm going to look and I'm going to say, now I do have grouping symbols. So this is negative 6 squared. A negative number raised to an even power is a positive. The very last thing that I'm going to show you is, well, no, I'm going to end right here. Thanks very much.